me take control. I need to share.
You should be able to share your screen by.
Yeah, that's what I'm going to do.
Yeah.
Share. I'm going to share screen 1. So can everyone see that?
Everyone see it?
Yes.
Yay.
Okay.
We can
Awesome.
all can you expand it to be full screen and then I'll
It
make mine.
is. It is full.
I should be able to make mine. Can I make? There we go. Full screen.
Okay.
Dismiss.
So
Device
we're all
settings.
good.
Can everyone see that better now? Yes. Excellent. Okay.
Okay.
All right. Thanks, Chris. I'm going to let you introduce yourself because you know more about you than I do.
Okay.
And thank you very much, Chris. We met in July, and
Yeah.
I'm super excited because he gave us a list of different presentations that he could do, and we chose this one. And
Yeah. So this one is probably my favorite. So this one will be fun. So, yeah, I appreciate everyone coming and being flexible. It's hard for me to sometimes get to user groups, so it's actually kind of nice being remote. So if people do have questions, just let the organizers know, and we can stop and get those questions answered. So, but we're going to talk about architectures and how to architect web APIs. So ASP.NET Core 3.1 web APIs. But if you're still using Core 2 or 2.1 or 2.2, these same philosophies will be used in those versions of ASP.NET Core. Okay, so my name's Chris Woodruff. Back last July, I used to actually work at JetBrains, and I left in August, and in September I joined Quicken Loans. So I work for Quicken Loans as a strategic or a platform strategist. So it's basically just I help strategize the future of Quicken Loans and Rocket Mortgage and stuff. And we also are hiring remote people. So if people want to join Quicken Loans, reach out to me and we can talk. We're always looking for good developers and business analysts and data people. So yeah, so I think we have 200 openings right now that we have to fill this year. So we have a lot of space. But you can see my email is out here in my Twitter handle. So enough about me. Let's get into the talk. So when I first started doing this talk about a year and a half ago, 2 years ago, I kind of started taking a look at what I did wrong. And when I say what you and I do wrong, it's mostly what I did wrong, because I've been doing API development for about 8 years. And I can tell you 8 years ago, I didn't know what I was doing. And some people might think I still don't know what I'm doing, but at least I have a better idea of how to do this. But I did this talk because I wanted to make people aware of some of the bad habits I did and not to do what I did. So we'll talk about those bad habits to begin with. So one bad habit is this idea. We always look at the Microsoft demos and we start using those demos as a basis for our development. And you know what? A lot of those demos are really quick and easy and don't actually give good architecture practices, like this one. Like having controllers and actions and putting all of your data access code into those controller actions, probably not the best idea. So don't do that. If you have, I used to do that, and we'll talk about why it's a bad habit in a little while, but it is a bad habit. Another bad habit is putting all of your code in a single project. One, it gets really hard to test, and it also kind of breaks the dry principle of just decoupling your code. And we'll talk about why in this architecture I talk about we should decouple code and break things out.
I'm just trying to minimize this.
Okay.
There's a little thing on the screen, but it's not going to let me minimize it, so I'm going to stop.
Okay.
Otherwise, it's gonna blow.
Here, I can, maybe it's on my side.
No, it's. Oh yeah, maybe it is you.
Yeah, it is on my side. So there we go. So I didn't know what that was coming from either. So this is the first time I've actually used Teams for remote talks. So again, another bad habit is coupling your data access with your project domain. And when I mean project domain, I mean your business rules and your validation and all that. It needs to be decoupled because one, data access, your project domain, your business domain shouldn't know anything about the data access. It should say, you know what, if I get this from Oracle, great. If I get it from SQL Server, awesome. It shouldn't really care. So just don't couple your data access to your domain, and we'll look at how I do it in my architecture and maybe give you some ideas. And last but not least, and I think we've gotten over this hump in the last 3 or 4 years, but think about testing at the beginning. So I will admit that 10 years ago, 8 years ago, when I was doing development, we really didn't think about testing. Like how we did testing was we ran the application, made sure it worked, and then we kind of threw it out to production. So, but there's so many easy ways to talk about testing, and we'll talk about in a little while towards the end of the talk, we'll talk about unit testing and what we call integration testing. And there are two different types of testing that we can do on our web APIs. So at this point, I like to talk about what ASP.NET Core helps us with. And usually when I'm in front of a bunch of people, I ask them what their favorite things are with ASP.NET Core. So, you know, I'm going to try this experiment, even though I'm here in Grand Rapids, Michigan, and you're there in Indianapolis. Tell me what you like about ASP.NET Core over like ASP.NET Core, ASP.NET with using the .NET framework.
Well, I know one thing that I've really enjoyed because I'm also a Xamarin developer. Can you hear me okay?
Yep.
Cool. Is the ability to share my code across multiple platforms. So I'm no longer kind of playing around with, hey, what version of .NET Framework are you working on now that .NET Framework's so mature? Now it's .NET Core is actually also mature, and I can, like I said, do cross-platform development with it. So that's really because you're usually tying some sort of back-end API powered by ASP.NET Core with your mobile app. And it's insanely easy. Plus, because it's cross-platform, there's a whole bunch of other tools that are open with OpenTeam.
Yes, there is. Yep. What else? Anyone else?
Building the services in the startup. I don't know the terminology for it, but just being able to, I guess, inject those modules.
Yeah. Dependency injection. Yep.
Yeah.
Yeah, so that's awesome. I love dependency injection built in to the foundation of .NET Core. So to go back about cross-platform, actually, I love developing .NET Core on Linux. So I have a Linux laptop that uses Ubuntu, and I use JetBrains Rider. So that's the IDE I'm gonna use in this talk, so you guys can see it. Currently, I'm on a Windows machine, but I have Rider working on a MacBook Pro and Linux, and I love all the platforms, but you know what? I do love Linux. It's just fun to do .NET on Linux after 20 years. So,
What do you use for your development environment on Linux?
Rider, JetBrains Rider, same app. It's the same keystrokes as what you get on Windows, so I like it because I don't have to change anything. So, anything else that people like?
No. We got 50 people. Anyone not want to say something loud? There we go.
The disappearance of a synchronization context is nice.
So the disappearance of a synchronization context is nice.
Yeah, that's yep.
And then what else? Did you have what?
It's the path forward. It's the only .NET going forward.
He feels like there's no other way.
No other way. Yeah, it's hard to go back to .NET Framework.
Yeah.
It's hard to go back to the dragging that system.web around all over the place. So there's a lot of things. So I just love what ASP.NET Core gives us, and we'll talk about some of those. So if I'm going to really talk about APIs and building APIs, we also need to talk about understanding the HTTP protocol, or HTTP protocol. I always put another T in there for some reason, but I do a talk on this. It's actually an hour-long talk just talking about the language of this protocol, and I talk about using the verbs and using response codes and using the entities and URLs, but there's a whole language with this that you need to understand, not only as a producer of APIs, but also as a consumer of an API. Because if I send back a 402, or if I send back, let's take an example. You want to get something. If you want to delete an entity, and I send back a 204. What does a 204 mean in terms of API, do you think? Anyone have an answer for that?
Success, no content.
Success, yep.
No content. Yeah.
And no content. So by me sending back a 204 when you're deleting something, why do I need to send back anything in the response body of that call? I don't. So, but I need to tell you that so you don't check the response body. So by sending back a 204, you automatically know I don't need to do anything with the response body. I can just get it and move on. And there's so many different things with the HTTP protocol that gives you that ability. So just understand it. I don't expect anyone to read the whole protocol. I haven't. I've looked at it, and I've read some books that go over the HTTP and HTTP2 protocol, but just understand some of the protocol in terms of APIs. So let's get into how I build my APIs. So I have this pyramid that I use to show the 4 parts of my API. So one is the API project. So this is the part that I receive the HTTP requests and I send back the response. And other than that, there's not much else that this project does. I mean, at the startup, it brings everything together and puts stuff in the dependency injection container and gets everything ready for the API to run. But I'm going to show you what this API project looks like, and it's going to be really thin. And we'll talk about that in a little while. The next section is this middle section called the domain. And the domain is really the guts of my entire architecture. It holds all my entities, and it holds my what I call API entities, and it also holds all my interfaces so that different parts of my architecture know what to do with and how the application has to be built. So we'll go over that also. And then there's data. So data is my data access. I can have multiple of these data access, and I'll show you 2 that I have, but I can have as many as I want because of how they're built with interfaces. And this is basically just where I have my data repositories, and I get my data back and forth. And all it does is get data. It doesn't do anything else. And the last part of my pyramid is tests. And as you can see, if I didn't have this section in my architecture, the whole pyramid or the whole thing would fall down. So tests are really important to have in this architecture. One, just make sure that if something gets changed, that you can run these tests and they can make sure they can verify that everything is working correctly. So this is how I kind of build out my APIs. And so let's take a look. I'm gonna bring up if I can get this. Okay, there we go. So everyone should see my IDE at this point. You guys can see it, right?
You might want to expand that a bit, like zoom in.
Oh, really? Okay. Well, let me do that. I thought I made it pretty.
So what you can do is you can just press Windows plus, and it'll automatically.
I'll make the text a little bit.
Okay.
Let's make the. I mean, I do that. So is this not, people in the back can't see this?
You see it? Okay.
I can see it.
Okay. I just want to make sure. So.
But you can increase the,
I'm hearing an echo. Is that me or is that someone that wants to ask a question?
Oh, I said something.
Oh, okay.
Just when you show the code, I would increase the text editor size.
Yep, I will. It should be pretty big, so I'll let's open that. And you know what? Somehow this changed because I had a bigger font. So let's do that. Let's do that. See. That doesn't seem to. Is that big enough or is that too small?
I'd bump it up to like 28 instead of 22.
Okay, we'll see. Let's see if we can. I just don't want it to roll over the edge of my edge of everything, but we'll make it bigger. Okay, is that better?
Yeah. Okay.
Okay. Good.
Thanks.
Yeah, no problem. It's good to have feedback. I can't see the screens that you guys have there. So we have 7 projects that we have in this demo for my architecture. One, again, we have the API, we have the domain, we have tests. I have some mock data that goes with some of the tests. And then you can see that I have 2 data. So I have one data called EF Core and one called EF Core compiled query. Now, I've been doing this talk since .NET Core 2.0, and at that point there was a feature in EF Core called compiled queries that worked great. it's broken in EF Core 3 and 3.1 because of some changes that C# and .NET did with the async enumerable interface. So, but what really these two data give you is the ability for me to have two different projects that I can switch. So one of these was EF Core, and the other one, I used to have a Dapper one, and I could switch between EF Core and Dapper and not have to change any of my code in any of the other sections, and we'll look at that. So this is just how I break down my architecture. So if we take a look at the API, and I bring up my startup, you can see that it's like any other startup, except I do, when I go in my configure services, I do like to break out everything and have some external configuration calls. So I do have some like services configuration. So here is how I'm going to be adding all of my data repositories into my dependency injection container. I use the add scope, and I put those in. So I have a configure repositories. I have a configure supervisor, and we'll take a look at the supervisor in a little while. Middleware, since we are not really .NET Core 3.0 has replaced Newtonsoft JSON. I have removed that from, because we're using the built-in JSON library that comes with .NET Core 3. And then I have some logging. So you can see that I could have all this code in my startup, but I try not to. I try to kind of break that up and make it more organized. So it's just I guess I'm a little anal when it comes to this. The other thing that I have in my startup is I do have Swagger. So we'll take a look at that, but in this example, and you can download this example from GitHub, and I have a link at the end. It does allow you to do Swagger gen, Swagger. So if I run this, let's run this and see what it looks like to begin with. So I always like to run this to show what this API looks like in the beginning. So let's just start this up.
Hey, Chris.
Yeah.
Is the Swagger generation built in now?
No, you have to actually add it as a now. After I run this, I'll show how you can add it through a get package.
Oh, okay. Is that swashbuckle?
Yes.
Okay, gotcha.
Okay, so this might be a little small, so let's increase this. So here's the Swagger, so I can come in and just say album, and I can say execute, and it's going to come out, and there's all of my albums that I have in my database that I'm pulling out through this web API. So pretty easy to use. I'll take a look in 1 second for how to add Swagger, but I do want to explain the database I'm using. I use a demo database that was created by Microsoft a number of years ago called Chinook, and it represents a fake online music store. So I like it because it has music, it has albums and artists and tracks, and I think those are more interesting than bicycle parts myself. So I'm not big on some of the other databases that Microsoft uses for demos. So in here, if I take a look at the NuGet packages that I have for this, I have a number of Swagger. So I do use Swashbuckle, and you have Swagger, the Swagger Gen, and the Swagger UI. So we do have those 3 NuGet packages that I use. And You can set up this, you can add the Swagger Gen to your services and then give it the Swagger doc, and it will give you a lot of this information that will then populate your Swagger instance. And when it runs, it'll kind of propagate all these details out into that Swagger document. So let's take a look at the controllers. So in this database that I generated using EF Core, I do have a number of entities. So we have 12 different entities that we have. And if we take a look at like album controller, which represents the album entity type, you can see that I really don't do very much. Like this is a get, so this gets all my albums. I am doing nothing except in here. I'm just calling a supervisor to get all albums, and if I catch an exception, I'm going to send back a 500. Now this might, for demo purposes, I am not figuring out based on exception, sending back a specialized 500 error. You could catch different types of exceptions coming back, and you could assign different 500 error codes to those response codes. But you can see that I am not doing very much with my actions. I basically do a very minimum. Like for get, I just basically check to see if my album comes back. If it doesn't come back, I'm going to send a not found. If it does, I'm going to send back an okay. And that's all I really do in here. I am not doing very much because it's just the API layer. And I'm going to jump back to my presentation now, and I'm going to talk about the API layer that we just looked at. And the API layer, I view it a lot like the UI of a ASP.NET MVC application or any web platform pattern like MVC pattern. To me, the API endpoints, they should not know about the domain, and they certainly don't know about the data access. All they're really there for is to get the HTTP request, send out, get something back, and send it back out, and with the correct, either with the correct successful response code or with some type of error code going back to notify the consumer of the API. One thing that in this architecture, I interact with consumers using what I call API models, which ensure a little better flexibility than just using the entity models that are generated from Entity Framework Core in my case. And we'll talk about that because I want to have a little more flexibility. So if I say, you know what, I want two entities put together, kind of brought together into one larger entity, I can do that, and using this API models. Now, some people call them DTOs, but for me, their DTO just isn't natural for me, so I call them API models. And like one example that I have in this architecture is that I send back an album, and an album entity type has a number of different properties. It has the album ID, has the album name, and it has the artist ID. But for me, if I send back those three pieces of information, it doesn't give enough information for that album, because I would want also the artist name to go back from the API. But if I use the entity model, I couldn't do that. So that's why I use a separate set of models that I interact with my API. So in my API model for an album, I have, in addition to those three properties, I also have an artist name that goes across the wire also with each album. So that's why I have this, and I'll show that when we go into the domain, because this is part of the domain. But I like to at least talk to you guys about how the API layer interacts with the consumer of the API. So the domain layer, and let's just talk about the domain layer, then we'll take a look at the code. So domain layer, it's going to contain both my entity models and my API models for the solution. Now, when I generate in the beginning, when I generated my entity models, because I use code first, database first, in terms of using Entity Framework Core. When I generate all my codes, when I generate my entity models and my DB context, all those live in one project, but I actually take those entity models and bring them into my domain layer, because one, if I'm going to have multiple data access projects that I'm going to be able to use with this architecture, I want to have those entity models being used across any one of those data access projects. So that's why I keep those entity models along with my API models in my domain layer. My domain layer also contains all my interfaces for data retrieval. So I keep a well-defined standard for my data access. So if I ever had to build another data access project because I'm going to be getting data from Azure Cosmos DB or something, those interfaces will tell that new project, will give the contract for how I expect the data retrieval code around the data repositories to be defined. And we'll take a look at that in 1 second. And then the great thing about .NET Core and ASP.NET Core, like someone talked about, it allows me to use dependency injection for repositories and other things throughout my domain layer. So my repositories can be taken from the dependency injection container and used in my supervisor. So I have kind of this object that I call the supervisor, and really what it is, it's a black box. It interchanges my API models and my entity models back and forth. So it does transformations along with caching, along with validation. Now I don't have any validation in this demo because I'm actually reworking that because of the old validation stuff that I was using in Core 2.1. 2.2 is broken in 3, so I had to kind of remove it for this demo to run it on 3 and 3.1. But in my supervisor, I could put the validation and business rules in here also. So my supervisor is really, it is the brains of this entire API architecture. We'll take a look at that in a second. So as a matter of fact, let's take a look at that right now. So I am going to close those. I'm going to open up my domain. As you can see, I have a number of different folders. I have a folder with my entities, and all my entities are just like they were generated from EF Core. I do have a convert, so I have a little method that will convert something, in this case, an entity model into its corresponding API model. So I do have that, but I just have a very simple entity model in here. And if I take a look at the API models, I do have a corresponding API model to every entity model. And in here, I have almost the same thing. I have a lot of the same information. I have that convert. In this case, this will convert back to one of the to an album entity model. But what you can see is what I talked about. If I jump back here, I have 3 properties in this entity: album ID, title, and artist ID. In my API model, I have an additional property, which is my artist name. So this gives me the flexibility to have to allow new business rules or new requirements not to break my architecture. So if a business analyst or a stakeholder came and said we need this API to do XYZ, I could probably do that because I have this flexibility between the 2 sides of these 2 model sets. So I also have some extensions. All those converts are extensions, and you can take a look at those, how they convert and using that. But it's I could use some third-party tools like what's the Jimmy Bogart library that slips my mind. Anyone?
AutoMapper.
Yeah, AutoMapper. Now I could use AutoMapper in here, and AutoMapper is a great library to use. But in this case, in this demo, it's a little overkill, and I don't really want to make someone understand AutoMapper just to do some simple conversions. But you could replace my convert methods with AutoMapper, and it would still work great. So let's take a look at. I do have a repository. The repositories are just all of my interfaces, and these are my contracts that we'll look at later when we take a look at the data access properties or the projects. So each one of these just gives a contract out what I expect from each one of the data repositories that will be developed for the data access project. And last is I have, actually it's a giant class that I break out across partial classes. So as you can see in here, I have this Chinook Supervisor, which takes in all these read-only properties for all the repositories. And what I'm doing is in the constructor, I am getting all those same repositories from the dependency injection container, and I'm assigning those so I can work with them in the supervisor. And where these repositories come from, it's kind of interesting. I can have them come from any place. I don't care what data project they're coming from, as long as they abide by these interfaces. So I'll show you in a second how I can switch out these repositories, and I can say, well, I want to use these repositories for this, but then later I can switch them out for a different set of repositories. So we'll take a look at that in a second. But I do have this partial class, and as you can see in here, it's every one of these files contains just a partial of this Chinook Supervisor. But I broke it down by just the functionality for each entity type that was in my API. Now, some people might be thinking, well, why didn't you create a supervisor for each different entity type? And my question to you is, why didn't I do that? Does anyone have an idea why I didn't do that? Why I have to have a one giant Chinook supervisor class? Nothing? No one has an idea? 50 people? I should give out a prize or something. Any ideas? There are no dumb answers.
You can do it up pretty easily.
You know, one idea is that you, if you try to assemble a larger entity, then you end up having dependencies on other supervisors.
Yes.
And
Yep.
so, yeah.
You nailed it on the head. Circular. If I created a supervisor for every single entity type, I would have circular references, because as an example, albums reference artists and artists reference albums. So I spent about 3 months trying to figure out how to get around this, and I've talked to many smarter people than me, and they're all like, just go with one giant supervisor and just break it out into partial classes. So that's what I did. So let's take a look at as the album supervisor functionality. So what I have is, I'm gonna, if I can move this over. In here, I have a GetAll. So we took a look at the album controller get action, and that was calling this GetAll albums. And what this GetAll albums does is we're going to call the album repository, which was taken out of the dependency injection container, and we're going to do a GetAll. So that just says I'm going to get all my albums, and then I'm going to convert those. So I'm converting those from album entity models to enumerable of album API models. And then what I'm doing here is I am pushing those into a cache. So we do have memory cache. We do have the ability to do cache within our code. And I'll talk about caching, the different types of caching that you can do with your APIs after we talk about all the different sections of our architecture. But in here, I'm just pushing all those albums into my cache. And I should probably check to see if that album is in there already. That's probably something I need to do just to check if that album's already in the cache. Don't put it in there again. But then I return those albums, and I can move on. So if I do want a album by one ID, what I can do is the first thing I'm gonna do is I'm gonna check the cache to see if that album lives in the cache. If it does, I'm gonna return that cached API model for album. If it's not, I'm gonna get it from the repository. I'm going to check to see if it's null. I'm gonna convert it, which I could convert it up here, but I just convert it here. And then I'm gonna put it, get my artist name. So I'm going to assign the artist name, because remember, when I get an album, what I want, the API model needs the artist name to go back out from the API in the response. And I'm gonna add that that album to the cache, and I'm gonna return that album API model back. And it's just that simple. Like if I want to get album by artist ID, which means that I want, based on an artist ID, I want all the albums that artist did. I have another call. So I have a bunch of calls. I have add album, update album, and delete album. So nothing's very complex in here in terms of how this repository works. Now I could have a business rules in here. I could have validation. I could have something, maybe if I add an album, I check to see if the artist ID that goes along with it is also a valid artist in my database. So that could be a validation I could do in this add album. So there's lots of flexibility in this. But the thing about this supervisor is that it doesn't care about where the data is coming from or where the data is going to. It just gets a request, calls the repository that it found in the dependency injection container, and because it abides by the contract from the interfaces, it just knows that it can get the data that it needs, and it will get that and then convert that and push it back out. So as you can see here, when I add an album, I'm going to take that API model that came in from the controller from my API request, and I'm going to convert that to a entity to an entity model, and I'm going to use that entity model to add it to the album repository. So it's this version back and forth that the supervisor does. Also with caching, also if you have validation or business rules, this is where everything would live and exist in. And that's really what my supervisor does. There's not much else in here. It is kind of the biggest project in terms of what I'm doing, but it still isn't very complex. But what I'm doing with this domain is I can test the domain independent of data access, and I can test data access independent of my domain. So by breaking all these out into different projects, I'm actually allowing myself to have a decoupled architecture for testability, and I can find issues much quicker, more granular than if everything was in less than all these projects that I have here. Anyone have any questions at this point?
Yeah, I do.
Sure.
Is the caching functionality built in now in .NET Core 3?
Yep.
Oh, that's cool.
So it was actually built in. It was actually built in before. So let's take a look. So if I go back up to startup, let's go back to startup, because it's where I can come in here, and where did I put it? Add caching. So I have a configuration called add caching. So if I come up here and I say add caching, I can add memory cache. So that's what memory cache is, what the type of cache that you are seeing in the supervisors. And then I can also add response caching, and I'll talk about that in a second. That's more of a client-side caching feature that you can do. So, but we'll talk about that. But really, all you need to do is just say add memory caching, and you get the ability to come in and do this type of caching where you can basically come in and do this memcache entry options, and you can tell it how, basically I'm just telling it how many seconds it will exist in the cache before it becomes stale.
But is that for ASP.NET Core, or is that across .NET Core in general?
It's just for ASP.NET.
Okay, got it.
Yeah, it's an ASP.NET functionality. As far as I know, you may be able to use it. I've only used it in ASP.NET. Doesn't mean that you might not be able to use it, because basically when all I'm doing on this is I'm just adding memory cache to the pipeline. So take a look. So I don't want to steer you wrong. You might be able to use it, but as far as I know, it's only for ASP.NET. Okay.
Thanks.
Yeah, no problem. Any other questions about the domain?
I have one question about your supervisor pattern.
Okay.
So you've got one partial, or you're taking advantage of the partial classes. At what point in a significantly complex application do you either break that out or make a decision that it needs to be broken out to more than one supervisor or more than one project? Or what's your decision point there?
Sure. So if I had a database, so if we have a database where it contains multiple schemas, so say like most of us sometimes only do DBO at the DBO schema in our databases. If you had some that had maybe multiple, and you knew that those schemas didn't overlap, or they didn't cause circular references, you could kind of create multiple supervisors to break those out depending on the schema of your database. So I will say that I haven't tested that, but I have thought about that. It probably would depend on your database schema. But
So you're just following the standard supervisor password though, or pattern?
Pattern. So this pattern isn't like a true pattern. It's just it's actually the smelliest part of my architecture, and I'll fully admit that it's probably the part that I don't really like. I don't like it because I'm not a big fan of having this giant class that contains so much code, but just is what it is for this purpose. But if you can identify based on your database schema, you could create different supervisors as long as those entity models and the API models didn't cause a circular reference.
Right.
Okay, so I'm gonna go back and talk about the data layer. So the data layer is where I say where all the heavy data lifting happens. It's where all the data access happens. I have everything defined on interfaces from the domain layer. So all of if I created a different data access project for 7 different relational database engines, as long as I use the same interfaces, I can switch out the data access project and in the repositories where the supervisor, the domain supervisor, would just get whatever was in that dependency injection container and use it. So it doesn't care what data access project it's getting all this information from, as long because of these interfaces and the contracts within those interfaces. And I use for this demo, I am using Entity Framework Core 3.1, but you can really use anything that is .NET Standard 2.1. So I have another repository in GitHub where I do the same thing, but I do Dapper, and it's basically the same architecture. It just, I use Dapper instead of Entity Framework Core. But I could have that Dapper data access project in this same solution, and I would have to slightly modify maybe my entity models to be a little more generic, so they're not totally they're not within the bounded context of Entity Framework Core, but I can switch those out also. And then my data layer, I have a mock data layer I use for testing, and I didn't have any good pictures for data, so I used my favorite form of data, which is data from Star Trek Next Generation, which I will say I was 15 when this came out, so it was part of my childhood. So Data was my favorite character in Star Trek way back when. So, okay, at this point, I have kind of talked about the structure of my architecture. Anyone have any, before I move on to caching, anyone have any questions around, final questions around the architecture and the structure of it? No? Okay. So for me, caching's a really important aspect, especially with APIs, because you want your APIs to be as fast as possible, to be performant. And sometimes even if sometimes your data access, your database engine is close to your API, so the latency is not huge, but sometimes your API can exist in a totally different geographic location than possibly where your database lives. If that's physical because your API is in one data center at your company and the database is in another location, or even up in the cloud, if your API project is in Azure US East and your SQL Azure instances are in US West, there's still that latency that you can have, and that latency cause your performance of your API to drop. So there are things that we can do to fix that. And we've taken a look at one. We've taken a look at the in-memory caching that you can do within your application. So the three types of caching I'm going to talk about in this talk are response caching, in-memory caching, and distributed caching. So response caching is a feature of HTTP 1.1, and it's the ability to tell the consumer of your API that you're recommending that, or you're allowing the data that comes back on that response, HTTP response, be able to be cached wherever you need it to be cached on the consumer side. So by doing that, we would set up this attribute on our controller or our action. So if you set up this attribute with a response cache and you do a duration of 60, it's saying that the data that you get back in this response can be cached for up to 60 seconds. And how that comes across the wire is it's in the response header, and it will be this cache dash control public max age of 60. Now, this doesn't force the consumer of the API to do anything to cache this. It just is a header that says that the producer of this response is recommending that this data be cached for so long of a duration. So if you use Chrome or Edge, the new Edge, those actually will, and you call the API that has this response header in it, Chrome and Edge will actually save that to their internal memory, internal cache. And if you call that same API within the duration of that response cache, it will actually not call the API across the wire. It will get the data from its local cache and give it back to you. So your browsers actually respond to this type of caching. Now, if whoever programs or will actually calls your API using a Xamarin application or another web app or whatever kind of application, it's up to them to build in the code to respond to this type of caching. So just know. Now you can also tell the consumer of your API that you shouldn't use any caching for the response data, anything in the response body coming back. And to do that, you would send in this attribute of response cache location, response cache location.none, and no store of true. Now this will set up a different response header attributes for the cache control, and this just will tell the consumer of your API that not to cache any of this data coming back in the response body. Okay, so that's pretty simple, but it is pretty powerful if you're building a good API and you want to convey some more information back to the consumer of your API. So in-memory caching, it's direct caching on the producer side. So we took a look at that earlier in the talk. So I'm not going to show the demo again, but just know if you want to take a look at it, all this code is in a GitHub repository that I have a link at the end that you can download. So distributed caching is just the ability to cache across different instances or a cluster of API endpoints. So if I was using in-memory caching and I push this API out to Azure across 8 different instances, this in-memory caching would actually be a detriment to all those API endpoints that were living up in that cluster up on Azure, because each instance would handle its own caching. The distributed caching is really where we want caching that lives outside of the outside of the instances of our ASP.NET Core Web API instances, but can be consumed by those. Now, I don't have any demos around there, but what I can tell you is that we have quite a few different instances of that type of caching. We can use local Redis. We can use SQL Server for a cache. Now you might be thinking, okay, so I have SQL Server as my database, but then I'm going to have a SQL Server for my cache. But it goes back to the ability to have a local SQL Server that's close by. If you were storing this on maybe a local, if you had your own data center and you were building this endpoint where you had multiple endpoints behind a lazy load or behind a proxy, you could set up, and the database that you were getting your real data from was maybe it's over in a different continent because the data lives in Europe, but your API lives in the United States. If you could bring in a local SQL Server instance that would act like a cache that was next to your API. So you could have a local SQL Server instance that would just act like a cache that all of your different API instances would use collectively as a cache, and you could cache things that way. You can also use some of the caching features of the popular cloud platforms. So there's Azure Redis Cache, Amazon Elastic Cache, and Google Cloud Memcache. So these are some of the different ways that different products that you can use for distributed caching. So any questions on caching?
No.
Nope. Okay. So testing. Like I said, there's testing's very important. There's two types of tests that I do. You have unit testing, which everyone should know how to unit test at this point. I'm not going to really go over that. I do have unit tests in my demos that you can take a look, but I do like integration testing. So integration testing is actually testing the actual API itself from the outside. So what it will do is it will simulate the API calls and allow you to build unit tests like tests that will test the actual API calls. And we'll take a look at that in a second. And then I built some unit tests to cover the repositories and supervisors that we can take a look at also real quick. And also, a lot of times when I do an hour-long talk, I run out of time to demo integration testing. So I always have this thing where I actually did an interview a couple years ago with Robert Green out on Channel 9, where we talked about this integration testing. So you can actually go out to this out to Channel 9 and see this also. But the slide deck is also in the GitHub repository, so you can get this also when you get the code. So let's take a look at the tests. So I'm going to close down this. I'm going to close all of these. So I'm going to take a look at integration tests. These are actually really cool, and Microsoft only came out with this in ASP.NET Core. So this type of integration testing is not available in normal ASP.NET 2.2 Web API. So what I'm doing in here is, well, let's take a look at the dependencies of this, because you have to have certain NuGet packages in here. So I'm using XUnit for all of my tests, but I do need to have test host in here, and test host is probably the biggest one that I need, and I need the test.sdk. So as long as you have those, you should be able to do these integration testing quite well. So in here, I'm going to create, I'm going to have a HTTP client, which is going to be simulate the client, the consumer of my API. So in the constructor of this test, I'm going to create a new test server, which will be a new web host builder. It will use a certain environment. In this case, I'm going to use development, and then it's going to have this use startup, and this use startup is actually from my Chinook.api. This is the actual startup from the API that I showed off before. And what this does is it creates little internal web server that will run my API. And then based off that server, I'm going to create a client that will know how to call. It will know all the different endpoints within that API project. So because I have the server and I have the client, now I can call my APIs and derive tests off of those. So as you can see, I have a typical test that uses the arrange, act, and assert pattern for unit testing, and I'm going to get all my albums back. So what I'm going to do is I'm going to create a request, and I know it's a get because of the annotation that I have up on this test, and I'm going to say this is a new HTTP method using the method get, and then I'm going to call the request URI, which is API/album. So this is going to create a request to get all of the albums coming back from my API. And then down here, I'm going to use a client to send that request asynchronously, and I'm going to get that response back. Now, I can do a lot with that response. I can check to see how many albums came back. I can dig in and check to see if a specific album is in there. But for this demo purposes, I'm going to show two ways that you can just say that that response, that call on the API was successful. Either I can say the response and say ensure success status code, or I can do an actual assert to say, does my response status code equal a HTTP status code of OK? So these two lines are equivalent. So all I really need is one of them, but I put both of them in there to show the two ways that you can test, or you can assert that this test passes. And another one I have is I can get one album back from my database. Again, I'm going to have my inline database. I'm going to do a get verb. I'm going to have an ID of 1. And again, it's the same kind of setup. I'm just going to create another HTTP request, but in this case, I'm going to use album/ID. So it uses string interpolation to build that request URI string. I'm going to send that in asynchronously, get the response, and just check to see if that call was successful. but I could check to see if that that album that was coming back from the database was the correct one that I was assuming. Maybe I'll check to see what the title of it was. But I just wanted to show that how you do these integration testing. I like these because I can just run them and I can see if my APIs actually break. If they break, then I can go through my unit tests. My unit tests will probably give me some information. So down here, I do have unit tests that test out the repository. So I just do. I have some normal unit tests, and I also have. If anyone knows .memory, JetBrains has a NuGet package that you can install. It actually doesn't you don't have to buy it. You can actually use it. It will work in Rider, VS Code, and it will also work in normal Visual Studio. And what this will do is I can come in and check memory constraints. So in here, I'm going to get back all my albums, and I'm going to check to see if all my albums go beyond the one meg size. So I can check to see if memory usage is within a certain constraint. In addition, I also have just normal unit tests that will go out and get one and check to see and just make sure that they're running correctly based on my repository. So like I said, I've got these two different types of unit tests. A lot of people haven't seen the integration tests. So it is interesting. I think it's a great new feature that came out with ASP.NET Core 2.0 that you can use in your projects and also in your continuous integration pipelines. So anyone have questions on testing?
I did want to point out one thing, that if you're going to ensure a successful status code in a test, that I think that's good for any 200 level status.
It is.
So if you specifically wanted, say, a 204, you wouldn't want to use that, because that would
Yeah.
So I just wanted to point that out, that
Yep.
even, that's two ways of doing it, but make sure.
You're right. Yep.
Make sure it's what you expected.
Yep. So if you want to specialize, so if you want to do a unit test for a delete, you would want to check for explicitly for a 204. So you're correct on that statement. So thank you. So is there anything else? Is there any other questions? I'm about done. So we'll have a little open forum.
I did notice that when you were bringing in the test SDK, it said it was preview. Was there anything different about the preview version, or is that just what you get if you look at those references?
Yeah, so if I go out and check, let's go into the.
It was.
So these previews.
Yeah.
Let's see if those have been upgraded. So it looks like, I could upgrade those. I just haven't. They are 16.5.0. So I'm almost positive that they haven't changed anything, but I just haven't pushed those up. So nice catch. Anything else? No?
I have a question.
Sure.
So if you were doing any sort of like authorization on this API using like OAuth, where would you do like scope validations at? Would that be in the domain, or would you do that in the controller?
That's a good question. I would probably, you know what, that would probably be something that I would probably do in the controller in the API.
Okay.
Are you talking about the testing of that or the actual implementation?
The actual implementation.
Yeah, I would probably do it. I would probably have it done in the controller, and then because I would do it at the controller. But if someone has a case, you could convince me in another area too. So
Yeah, that's kind of not a blanket thing. So if you were going to do, first you got to think about authentication and authorization, right?
Exactly.
Then you want to be careful only doing that in the controller, because if you did it only in the controller, then any utility you wrote could bypass your authorization code. So even if you are authenticated, you might not be authorized. And that would be a problem. Yeah. So yeah, I think when you come up with your auth strategy, you want to make sure that you kind of look at the structure of your application and your entry points and make sure that that stuff's valid. Like that's something that even in your supervisor, when when you're enforcing business rules, that's where you say, before I take this action, regardless of whether I'm reading or writing, I'm going to call another injected service to check, is user passed in authenticated to perform this action.
Exactly. I definitely would do that at the supervisor. I would do authentication at the controller, but authorization probably at the supervisor, in addition to the controller action levels. So just to be safe. Yep.
To be fair, you won't always have to budget to do that, and ASP.NET, kind of steers you towards the less secure way, which is all the attributes, which I've used a billion times, and as far as I know, I've never been hacked. So, but you need to be cognizant of it. So based on, I would consider that. You do a review with your team about, okay, did we do this right?
Yeah. The other thing is, if you were building this, that supervisor doesn't have to be just used against from an API, from a web API project. It can actually be used from anything. I could reuse that supervisor or reuse that domain and use it in a MVC, in an ASP.NET Core MVC app, or in a Blazor app, or in anything. So the other ability is to decouple that domain. Is I don't really care what is calling it too. So there you're gonna probably have some, if you're looking at Alt Z and Auth N, you're looking at some other strategies that you might want to take a look at from that domain side also. So to wrap up, because I don't know, it's 8:08, so yeah, I've talked for a little over an hour. I just really appreciate what everyone that everyone came out. Next time I will come down to Indianapolis, so maybe next year I'll come down. I appreciate you guys having me remote. This has been a busy week with work, and it was hard to get down there. But here's my Twitter handle, my GitHub account, my email again. But I have 2 URLs for sample projects. The first one is for the if you are still using ASP.NET Core Web API or 2.2 Web API. That top one is for that, and then if you're on to Core 3.1, you can use the bottom. So both of them have all the code for the corresponding versions of your .NET Core.
Sweet.
So, and the slide deck, the updated slide deck is in the second repository. So just know that.
Awesome.
Okay.
Chris, I'll make sure that we put a copy of the presentation in the meetup so you can also get a copy of it.
Sure. Okay. Thank you. And then I'll send, if you do need me to send a copy of this slide deck, I'll send it over to you.
Awesome. Any other questions for Chris? No? Going once? I mean, he'll disconnect from Teams and then. No? All right. Well, thank you, Chris.
Okay. Appreciate it. Thank you.
I'm gonna go ahead and hang up. So I'll ping you afterwards.
Okay. Great. Thanks.
Hey, thanks, Chris.
Okay. See you later. Thanks, everyone.
Yay. All right. Now I got to figure out how to. There we go. Yay.
I think I'm still